Hey friends, hope you're doing fine. Today I'd like to share with you a way how to use web scraping in two different forms. First one is the slow one, and the second one is the fast one using asynchronous requests. So async.io, which is a library in Python. So first, let's figure out what we do here. Well, there is a free API which is delivering Pokemon data. So which is this one here? So pokeapi.co, API and so on. And this API delivers information regarding Pokemon. I already opened the specific web page for the first Pokemon. So let me show it to you. And that's what the data looks like. So you can see there's a lot of information, in this case only for the first Pokemon, which is Bulbasaur, I think. So to show this to you, you can easily now use requests library in Python. So let's say import requests. Let's have a look, requests. And then we simply say, in this case, that our result equals to, and now we say requests.get. And we simply then use the URL in here. So let me copy this here, Control C to copy it, and I paste this inside. Just need to put it in quotes. And then I need to specify which kind of Pokemon I want. So if I specify, for instance, here a 1, and I will execute this, now the result is there. And if I take a look at it, result, it is a JSON format, so I can call .json to convert it into a Python dictionary. And if I execute this, then I can see that's what I get here. And you can see there's also the name and so on. So a lot of information. You can see it's a lot of information. So let's take a look at the data we get. So take a look at the keys of the dictionary. So what kind of information is actually in this result? Let me execute this. And then we can see we got some information about the abilities of the Pokemon, the base experience, forms, height, and so on. So if I, for instance, take a look at something specific, for instance, what kind of species it is, I can simply copy this if I want, Control C to copy it, and I can simply refer to the specific key. So meaning I can go in here, and I can put this in brackets, paste this inside, I can execute it, and then I get here the information about the species, which is this one here. Okay. So, and the same is true for all the other keys. Now, this is the normal scraping, right? So we simply use a request and we call an API, for instance. So down there, I already prepared something. So let me maybe just delete a few of those lines in here, and let's take a look at this one here. So the code itself is kind of self-explanatory, but let's go through it just to understand. I basically do exactly the same as we've done up here. So the only difference here is that I also import, let me just import it to make sure it is there. So import time, the time module, which is by default available in Python. Now I'm using a list here, specify a list poke, and this list simply then gets filled with the information. So meaning instead of only doing one request, as we've done here, where we say we only want the data for Bulbasaur, what we do here is say we go through all the Pokemon from 1 to 151, so including the original 151 Pokemon, and then we simply do the request to the specific number. So you can see here we're using an F string here, meaning the I here simply is then replaced with 1, 2, 3, 4, and so on. So to get all the data for the Pokemon in this loop. And then we simply append the results, so in this case the JSON, in this case only the name, to the Pokemon list. And then at the end, I want to also print the time. So let me just maybe do a line in here. So, and let's execute this. Let's do that. And we run it. And you can see that it works, but it takes some time, right? Because the API has to go through all the 100 and, in this case, 51 Pokemon and extract the data and then paste only the name, in this case, to the Pokemon list. So now we are done. And you can see it almost took 17 seconds. So if I would now call Pokemon in here, if I say poke like that and execute this, we can see that we got here all the Pokemon inside, right? So we got all the names. So obviously that worked. However, we see that it takes almost 70 seconds. So it's not fast. Now, let me show you the example with the asynchronous requests. So I import IIO HTTP and async.io. Asynchronous mean that simply that the requests are actually happening asynchronously. So not one after another, but actually as soon as there's free space, let's call it this way, then the next request is sent. So So basically we shorten the idle time. That's what we do. What I found out is when I want to run it in Jupyter Notebook, I also need to import those two lines here. So nest async.io, and I need to apply it. If I don't do this, then I get an error that the event loop is still running. So that's why I just want to mention this here. If you want to use it in Jupyter Notebook, you should actually also use those two lines probably. If not, then probably you could also try it without those two. Okay. So beside this, let's actually figure out how this code works. So that's something I don't need anymore. Can get rid of that. But down there, we see that we have another list, speed, same way as here, but here we specified it's Pokemon, and here we simply call it speed. Then we use also a timer, and then we define a function here, this main function. This function itself is asynchronously. So that's why we use the async keyword before. And we should do the same here, and we start a session, so a client session with AIO HTTP. So this asynchronous HTTP. And then we do the same as before. So we create a loop from 1 to 151, and then we actually go to the URL, and we specify here this session, and specify for the URL itself, we await, in this case, that's necessary if you have an async request here. So we use the await keyword. We await the JSON response, and we store it in Pokemon. And in this case, yes, in this case, I think it should be fine, yes. So then we append basically here to speed, so our original list, simply the Pokemon name again. So exactly, basically the same, but the main difference is that we use it within an AIO HTTP session, a client session here, and then we do this whole thing asynchronously. That's why we use the async keyword here. And then here we run the event loop, async.io.run, the main function. The main function is actually this one here, so the whole thing. And then we print the time again, and then we figure out how much longer or shorter this is compared to the 17 seconds we had here. So let's do that. Let's actually run the code. So let's run this. And then we wait until this code is run through. And we can see that it only took 4 seconds. And if I take a closer look, so we'll just execute this. So if I take a closer look at the speed here, so the speed list, speed, I can clearly show you that it contains the same data as the other list up here. So original one, which was Poke, which we created here. But the main difference, hopefully you can see that, is that this here took almost 17 seconds, or almost 18 seconds maybe, until it's finished. And the one with the async.io request only took 4.5 seconds. So that's what I call, well, speed regarding web scraping, okay? And that's it actually for this little introduction. So hopefully that was helpful. If so, then please give this video a like, share it with your friends, and also please subscribe to the channel. It helps a lot, and I really appreciate it. And of course, it also motivates me to create further videos regarding Python, regarding Tableau, Power BI, and other kinds of interesting topics. Just let me know, okay? So that's it. Thanks a lot. Take care, and hopefully see you in the next video. Until then, best guys.